Hello, good morning. Thanks everyone for coming. I'm going to talk today about data science, data in general, and cloud. My name is Constantino. Actually, this is myself having a journey through the mountains, watching and looking for interesting pictures around. I think my career is something like this, a small journey. I have got a PhD in physics, and in my career, I've been moving from doing science and data to somehow at this point data science. So it's a kind of convergence of my professional history into something that's coming up today as a mainstream activity, which is data science, data engineering, and all kind of data stuff. So let's explain for half a minute what's CAPSiDE. I work in CAPSiDE. We are a company that provide automation, agility, and DevOps and reliability to companies, and we basically do it through public cloud, open tools, and what we believe is the basics of our work, infrastructure and services as code. So we code everything. Everything is code, and our infrastructures and our operations are based on code. So we just program everything. So let's talk about what we're going to talk today. I'm going to talk about somehow the global picture where we today in terms of the world, but also in terms of technology and what might happen. And of course, I'm not going to give you a lot of answers. I'm going to give you a lot of questions. So you can call me if you want it a troublemaker, because I'm going to give you some troubles, what's going to happen in the future, and so on. I'm going to come back. I'm going to drill down a little bit into the picture of what's going to happen, or what might be happen today in the companies, which kind of challenges we have for adopting these technologies and the data challenges, which kind of problems we have to, include what might happen actually in the future. And also, at the end, I'll come to the practical approach. What can we do today with the cloud technologies that we have? So this is going to be the 3 steps we're going to go through. So through this journey, first question I've just came through internet through some other articles around, and I found one that said, is a strong artificial intelligence inevitable? And I read the content. It was not very, not very interesting because it didn't give it much clues, but the question is very important, I think, because it raises 2 things, 2 basic fears. First fear, should we avoid, strong artificial intelligence? And I'm thinking of something like Terminator, if you remember. So it's going to be a machine that's going to kill all of us here in the room in the next coming years. We'll have some fear of that. And there's some closer fear like, things are changing, technology is changing and everything, data is going to replace my job, and then I'm not going to have unemployment, which might be also, I think it's a fear that we might have at some point. So I think the question of this is more like, I don't have the answers, but what we thinking of for myself in the history, typically every technology has been, and at the end has progressed and has been applied somehow. The key question is, how can we use technology properly, which I think is the main, it's more a moral problem than a technical problem itself. So I don't have the answer for that one, sorry for that. So yeah, the question today, if we look at it a bit closer, we start to drill down a little bit, just a small step, is whether this, what we see today with the data science, is an evolution or a revolution. If it's an evolution, it would imply that things change a little bit. So we might have a new tool around, but that's it, we'll be doing the same stuff. If it's a revolution, everything will change. And I think we are somehow close to a revolution. If you look at you heard or saw some of the latest advances in artificial intelligence, there's an assistant that Google has shown a couple of weeks ago who was making a call to a restaurant to make a reservation. He was 100% undistinguishable from human interaction. So he was calling, he was having a natural conversation, there were some misunderstandings in the conversation as well. You couldn't distinguish the machine from the people. It's it was so feared that, for the people, disturbing, that Google had to say at the end, we promise that we will always identify this device has artificial intelligence in every conversation. They promised that to, low down the fears. But they can phone a restaurant with your voice, with your tone, with your way of speaking, and have a normal conversation. And that's fearing it a little bit. So in terms of, let's say, drill down a bit more and talking about people and fears, what makes a company If we drill down and see, well, how it might affect my company. We always, I mean, I've been in many companies, and we always said, people makes companies. And if we don't have the people, we don't have the company. And we don't have the people, we don't have the society. So this is CAPSiDE people, actually. And if we actually look at what composes the companies, there are typically three things. We always tell we need people, tools, and processes. So if you come to let's say, a big organization, you say, we need to deliver a new business unit, and they will say which kind of competencies we need, which tools we will use, and how we'll organize the whole stuff. And if you look at this picture from a company perspective, there are three vertex here, and there's also some connections between them. So you have people have to know how to use the tools, and people have to follow the processes. If you look at the processes, they have to fit with the people knowledge and with the tools, and the tools have to as well, have a common sense. All the three have to have a common sense. So going forward, if you think about data-driven companies don't exactly work like that. So if you look at the companies that are 100% data-driven, data is a key element. It's not in this picture, of a simplistic picture of three things. So data-driven, I'm going to go now jump a little bit into what data-driven means. So if we think about the official definition of data science, the official definition of data science is you've got data, that's what most companies want. They want to use data to get business value, which typically means money, or some business benefit, okay? And they want it as soon as possible. I want it in time. So you have a typical data science project. It could be, for example, I want to have a way of analyzing my data so that I know what's going to be the next trend, and I'm going to go to the market sooner than my competitors. So that might be one of those ways of using data science to improve your company, to improve your business, and to have more wealth and more, let's say, business. So you got to make this picture. Data is also relevant in these companies. Data-driven companies need also have a picture there. And then if we think about those experiments of artificial intelligence, we get processes and tools as well. So the picture is a bit more complex. You get more connections. So people have to know how to use data. That's a challenge. Processes have to accommodate data. Tools also have, transactional tools, typical business tools, have also to accommodate those new tools and data itself, because data is not in itself tools. Do you understand this point? So data is, if you have tools, data science tools, but you don't have data to train them, you have no data, which is the point. So actually, which are the challenges in many companies? And I'm now talking about companies, I'm talking, let's say, daily, about data engineering problems. So one of the problems is the data breadline. Because in our companies today, in Spain and in some other countries all around the globe, all those companies that are not 100% data-driven are not trying to move into the data scenario to use this technology. They typically did not have a good or a complete data warehouse and data policy to have the ability to answer all the questions of the employees. So if you are a sales director, you might have a report on how many things you sold. But if you are a sales rep, you might not have the information of how your next opportunity or customer, what's the needs, or what's the financial status, or what's the plans of the coming customer. And this is, for the sales rep, this is a very important thing. So if the sales guy might have this information, he might improve his work, which actually is the key point of the thing. The second thing is hybrid knowledge. That's what is a new challenge. I have a company who is trying to build some data science things, and people is trying to do it out of the, let's say, disconnected from their present knowledge. So if you're an engineering company that builds boats and want to use data science to build better boats, and you hire a data scientist team and you put it apart, and you got your engineers here and your data scientists there, and they don't talk each other, it's not going to work, because data scientists don't have the insights that the engineers have, and neither the opposite. So that's a little bit challenge. And also, data is all about discovery, which is my last part of the talk, and we'll come to that when I talk about cloud. So data breadlines look like this, and it's basically I have an example. I have a company who hired a whole team of data scientists. Those guys are supposed to be creating models, but instead of that, they are creating reports. And the reason they are creating 85% of the time reports is because the company had a lack of data, reports and processes to deliver data to everyone in the company. So you put more people with data abilities, then you get, eaten by the whole lack of information. So you get a data breadline. So everybody's in the queue waiting for the data scientists to answer their questions, which might not be so advanced, but they were waiting for years. Know what I mean? Maybe you have seen that before in your companies. This is more what probably could be the solution. I've seen some ideas around. For example, Facebook has a team of, has a whole process of onboarding where every employee is trained on the data framework of the company. So data-driven companies have policies that you onboard. You have a train for 2 weeks about the data framework of the company. Those are these data-driven companies. And they have all delivered, also they create some kind of framework and self-service buffet of data so that people can feed themselves instead of stand on the breadline. So going forward, this is the last, another challenge. This is your expertise if you are an engineer. This is the data scientist here. You've got to find a way to combine both technologies. For example, as I told you, I've got a client that actually make a phone call to Microsoft. Those guys are supposed to be the experts on engineering of their installations. They have a pretty complex installations. Think about more than 1 million data points, 1 million, some 20, 50,000 sensors around and motors and everything, and they have engineers. And they phone Microsoft and ask them, well, can you Microsoft give me a software that can do predictive maintenance? And that's funny, because if you know something about data, you need to understand somehow, you have to embed into the data science piece, you have to embed your knowledge on how things in the physical world work. And then you have the most performing stuff. I'll get kind of a bit surprised, but I think you have to join together those knowledge. So this is, for example, this is an example. Does anybody understand what it is? What it is for you? Just a lot of lines. You know what it is for me? It's money. And the reason this is a small diagram of a production of plastic production of with some material with what we call weak defects captured by smart vision intelligence cameras. The plastic is running at some 20, 30 meters per second. There's high-speed cameras capturing the quality of the plastic, and they are detecting small pitfalls. Those small pitfalls means that you can characterize your production. You can link it together with your let's say, design, which kind of plastic it is, which lot it is, which particular properties it has, how did they produce it, and you can really characterize your production and improve it. Or you can use a faster process if you know you're going to reach good quality or enough quality, and you can save a lot of money, and maybe even material, and even you're going to save as well, some material you're going to save also a little bit nature. So I have this thing here. You know what it is? Somebody knows what it is? Can you raise up your hands? No? No clue? Come on. How many engineers are here? Could you raise up your hands? There are engineers in the room? Any? No one? Nobody? Economists? Everyone? I'll get a lot of faces of engineers here. I'm sure some of you are here in engineers. So this is actually a side rule. It's an old version of a calculator. Logarithms, exponentials, everything. Every engineer in the 50s, 60s used this kind of thing until the electric calculator came out. You can see it? Have you ever seen one? Someone have ever seen one? No? Okay. That's from my father. Old stuff, but nice stuff. So, this is old, and this has completely disappeared. But, people still do engineering. These calculators, they use more, today not so much. Today we use pretty much spreadsheets. So we take a page, you put all the calculations there. But, yeah, technology happens to evolve, so data is coming to stay, and we have to live with it. So looking at or thinking about yeah, that's one question I'll pose myself. You can ask the rule, why did you come to this conclusion when he gave you a number? Have you ever, let's give it to my next slide. If we think about computer intelligence, it's mostly automated, has kind of some difficulties to handle high dimensionality, which humans at some point we can handle. It has massive calculation capability. And both of us are somehow, humans and computers, perception biased. And the reason we are perception biased is that typically when we capture data, it's a little bit biased. So this is not really an advantage of computers. And they have some limited learning abilities, and moreover, they have non-creative. There's no creativity in computers. On the other hand, you have some humans, we typically are good for exceptions handling. We have abilities to handle high-dimensional problems. We have some abilities to handle abstract modeling, emotions. We might be creative, which is, I think, a very distinct characteristic. We have some blind spot perception, you know what I mean? Yeah, so sometimes our brain makes us understand we understood something, but we didn't. And we try to go to the details, we discovered that we didn't really understand it. We are good at sparse data, and we are biased by emotions as well. So this might be a characteristic. It's not an advantage or disadvantage, it's just a characteristic. But in the middle of the whole thing, we might say that today we have natural language processing, we have vision analysis, we have car driving. Cars might be driven by computers, and we can diagnose some illness better than, computers can diagnose illness a little bit better than people. So there's some things that typically were pure human, and today are, getting computers do better somehow. But this is my perception. You got to have tools, you got to have processes, and you got to put together data and people somehow. And this is, I think, the clue for becoming successful companies in the world. So if you might do a good management of machine knowledge and people knowledge work together with the best of each one, that's going to be, I believe, what we could call, this knowledge, hybrid knowledge, or a knowledge that might be, spread across. The reason I wrote in the other slide that I was asking my slide rule, if it can give you any answer, is that there's a thing that typically humans do. If someone here, any of you resolve a problem, I can ask you, how did you resolve it? You can explain it to me. But if I ask you a computer, how did you resolve this problem? Typically, the computer is not able to explain it. So that's a difference, a relevant difference between machines and people. So going forward, actually, there's a book written by Kasparov. It's a nice book about how, in some years, I think it was in 80s, 90s, they were like comparing computers with people. And Kasparov himself, he created a tournament called Advanced Chess. And what's Advanced Chess? Does anybody know what Advanced Chess is? Anybody in the room? No? No one? Advanced Chess is a tournament where people play with a computer. So each player is a person with a computer. So in Advanced Chess, every single computer, the most powerful in the world, might be today, at least. One advanced chess player with an average computer like this one can, beat any computer in the world, no matter what. And they can beat any human in the world, no matter what. So the average, guy with a computer, even if he's not the greatest, he can match he can beat any machine and any person, which is kind of surprising. He wrote this book, Deep Thinking. I think it's a very interesting one. But the basic idea is the people in chess, people with computer deliver perfect tactical play and highly meaningful strategic plans. So you can really guess that tactical is computer. He's looking at the short term, which movement should I make? Doesn't make mistakes, not big ones at least. And strategic is human. Okay, it's clear? So this is kind of, I think, challenge, a kind of competency that probably companies will have to deliver and we have to fight for in the coming future. So I've got you something here. I was thinking about how can we do things. I mean, how to hybridize people knowledge. I guess you are not here. Is there any data scientist or someone who can consider themselves a data scientist? Could you raise your hand? Anyone? No one? Neither? Okay. So the thing is, if you're not a data scientist and you want to learn, don't need to learn all the stuff around data science, this is a new service. Like I think it's alpha or beta today. And you can use, for example, AutoML. AutoML is a tool from Google that allow you to actually do machine learning without learning machine learning. So it's putting some intelligence on some of the processes. There's intelligence, artificial intelligence, on top of artificial intelligence, so that you don't have to learn it to use it. It's not an API. It's really learning, so you can feed it with things to learn. So it's not an API where I give you an image. It's much more sophisticated. Simply, it's removing the need of having the technical details on how to train these neural networks and which kind of neural networks and which deepness and which characteristics and which hyperparameters, et cetera, it's doing automatically. So you can do machine learning without knowing technical details on neural networks. Okay? Got it? So this is making it easier. So last but not least, and I'm going to finish my, let's say, overview of the whole staff of this. This is a personal thought. We had a long time ago what we call TPS. Anybody know what TPS is? Toyota Production System. Everybody heard about Toyota Production System? It's the basis of all the lean movement that later on somehow became, or some of the ideas became the agile world, developed the agile stuff, and the DevOps, etc. Most of these ideas come from there. So later on, we had DevOps. And so in TPS, quality is not a step at the end of the process. What Toyota was doing was said, I don't want to have people producing stuff that later on someone from quality comes and say, this is crap, and throw it away. I want to have quality into production. And this is kind of the same idea. DevOps is operation of your software is not an afterthought, which means you cannot develop software without creating quality enough so that it's going to be run efficiently and effectively and giving good service. That's the key point. So DevOps actually is about not putting operation of the software or service of this software to people is not an afterthought. It's part of the development itself. That's DevOps. That's what all DevOps is about. And I've got this idea, DataOps. Data insights are not an afterthought. This is DataOps is defined today in the Wikipedia. You can find it. It's not exactly this idea, 100%. But I think, and actually, when you talk about DevOps, people write pages and pages, and they're not always saying the same stuff. But the basic core thing is this one. I think for data, there's kind of the same idea. You can't take a team of data scientists, take your operations, no matter what they're IT or selling a car or building a part or whatever, and put them apart and expect that to produce a lot of value. And again, I think this is going to be a trend in the future. I know it's going to come very fast, but I think it's going to be a trend in the future for sure. So I'm going to finish that part and go back. I'm going to go deep into the more technical stuff and talk about data and cloud technology, which is the kind of the last part of my talk. I'm going to talk about practical cloud stuff. So how can we do data science? And the thing is, data science actually requires, again, I'm going back to some of the ideas I talked at the beginning. We need data. So if you're in a company that's trying to do some kind of machine learning data science, you need data. If you don't have data, you cannot train any model, you cannot learn, because the knowledge is in the data, just you're going to extract it and use it. So you need data and you need experimentation. A lot of experimentation. Most of the, actually, let's say most of the time you are on the data science side, you are digging into data to find patterns. So you dig into data to find patterns, you are doing kind of what we call discovery. This is a discovery process. And afterwards, once you have discovered, you gotta industrialize the whole stuff. This is how data science today looks actually. So you have a lot of data. You actually search patterns inside the data. And if you find some patterns, you've got to take this let's say, knowledge and put it in production somehow into your operations. That's what I was thinking on, that's what I call DataOps. If you have it properly, I mean, you have a set of good practices where this works in a very easy and effective way. This could be the data of good practices, which don't exist today. Today we have DevOps good practices. There are a lot of standards. They work fine. DataOps still much immature. But I think in some years we'll have a much higher maturity. So we need those three things: data, discovery, and industrialization. Discovery is a lot of our trend. A frequent story I had with some clients, and I'm talking about the concrete things, is that people had a lot of Ansible, Mesos, Spark, Kafka, and Hadoop, and they have not made yet any discovery. They bought a huge, a huge cluster of big machines with 70 terabytes of RAM and 100 terabytes of RAM just before doing any data analytics, any data, and digging into data and discovering the patterns and everything. And it doesn't make sense. So it's like if you're building a production plant to build cars, but you don't still know which kind of car you're going to build, or it's going to be a truck, or it's going to be a boat, So you're building something with the expectation you put data there, you're going to get some value, but it's just, it doesn't work like this. You have to first find it. And to find it, you don't want to put this big investment. So the thing is that typically why do people do that? Because most of the clients I know, they start those processes or those projects like if it could be a software project. Because data projects are done somehow with software and require developers and require computers. People think, oh, this is a software development project. Well, we follow the same standards. And how do we develop software? We look for the platform. Oh, it's going to be Java. It's going to be this library. It's going to be blah, 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 blah. And once everything is defined, they start working. But this doesn't work for data science. And the reason it doesn't work is because software development is not data science development. They're totally different animals. And the basic differences are to do with the software development. You have a certain, you're not so much uncertainty. And it's mostly about engineering, building, to think that your business guy knows what he wants to have. So there's no uncertainty in what's the purpose, the final purpose, where it's going to work. And data science development is about high uncertainty and experimentation. It's about finding things on data. So experimentation is the opportunity. So if you can, experiment things, if you can really do it cheap, so you're going to try to find something, you wouldn't want to invest a lot of money. You just want to try it, so you want to spend as less as possible, and of course you're going to have trial and error. So if you're going to have this algorithm in Spark and it doesn't work, and afterwards you want to go to R or to any other technology, you just don't want to have paid a lot of money for this platform. It doesn't make sense. So it's all about also looking for new approaches and actually using new tools. So the availability of tools, easily reachable, and you don't need to have anyone who install them. Don't need to long times of preparation and building, etc. This is a key point. So, and blending the whole thing together. So this is what we need in the end. In on-premise, well, I found a lot of people. We had actually people yesterday in Zurich that had a big cluster of on-premise servers, and they're thinking about moving into cloud at some point. But in on-premise, you get to invest a lot. You get a lot of time to configure. You have a rigid fixed scale, and it's too hard to try for fun. And this is a key point. It's too hard to try for fun. So you gotta wait weeks for your servers to come and to install them, and et cetera, et cetera. And afterwards you realize, oh, I better use another technology. It's gonna be crazy. Your IT people is gonna scream around. So cloud is just the other way around. It's just pay per use. In 5 minutes, maybe 6, it's up and running. It's scalable. And actually, it's easy to turn on, try, and off again. And the most important thing is you get all kinds of tools. And you have to, if you look at the different providers, you can see that most of the requirements you might have from data science, you have covered them. Actually, these guys, Amazon, Google, Azure, Microsoft, actually, they are fighting like crazy for capturing data scientists' interest and having every data center in the world working in their platform, because this is going to be a lot of revenue for them in the future. So if you remember, fightings for the operating system when Microsoft and Apple and were fighting and trying to attract developers to their platforms. So people, Apple wanted to have developers building applications for the iPhone, and the platform that had more applications and more algorithms and more things were the winner. Actually, this kind of same stuff. The technologies are very similar. Some of them are compatible, but not 100%. So if all my best data scientists in the world use one of the platforms, this is going to be used by almost everyone. So they're fighting like crazy to deliver the best available tools. So that's a key. Instead of paying hundreds of thousands of euros or to buy a particular tool in the market, or millions, to build up your own stuff, you can, for $3, $10, have access to the highest, most advanced tools in the market. And does anybody knows what it is? What is this? Anybody can raise up your hand? Nobody knows what is this? I'm surprised because this is very well known. So this thing is not a normal computer. Anyone? The sounds TPUs? Yeah. Yeah, TensorFlow processing units. So those are TensorFlow processing units. So those are, the key point is you can build that on your on-premise because you will never have the money to, let's say, build, create, and produce hundreds of thousands of processors ad hoc for your purpose, but for yourself. And this is the way Google is industrializing this thing. So performance of neural networks in a CPU, let's say, is 1. Performance in a GPU, in a graphical processing unit, is 10 times. Performance in one of those is typically 100 times, so 10 times the GPU. So compared to same scale of, let's say, price and watts and power consumption, et cetera, et cetera. So this is the future, and you will not find it in, let's say, your data center, I guess, I hope, probably, right? So the final conclusion of this part, the last part, talking about concrete things, and cloud is, if you want velocity, if you want to have cheap experimentation, if you want to have elasticity, you want to have tools that are very advanced, you want to have industrialization, you gotta go to cloud, and data science loves cloud today in our society. So thanks a lot for your attention. We've got some 4 minutes more. So if you got any question, I can answer anything you want to ask for. So is there any question in the room? Anyone want to ask something? Anyone that have a different, has anyone thought a little bit about how he's going to digest the new data scenario in his daily work? Anyone? Any idea? You raise up your hand and you think differently from 20 minutes ago when you came? Did it raise some fears? Any one of you have some fear of, whether the machines are going to take my job?
You commented about that, and
yeah.
Some weeks ago I watched a documentary especially about how the automation and robots and so on are stealing or
right.
taking jobs of people.
Yeah.
People who has been working for maybe 15 years, 10 years, doing, I don't know, the typical management things.
Right.
Have been replaced by automation tools, so automation robots.
Yeah, so from automation robots is a new trend. There are some typical traditional huge robots in the production lines that produce big parts, which weigh some hundreds of kilos. But today you have what we call soft robots, which work side by side with the employees. So they can produce, they can help you to do some repetitive tasks very easily, and they're compatible with people because the old robots were not compatible with people. You have to make a closure around because they could crush a guy. And the new ones are much smaller. They take small things, but they're much smarter. They're easier. And there's one company in Denmark actually. I work with them a little bit. They produce robots that you can teach. You teach them. So the thing is, the people becomes much more productive, so you need less people, which actually is a trend that's coming from the industrial, from 2 centuries ago. The thing is, that some employments that we thought will never be done by machines today might be done by machines, for taxi drivers, for example. So in 5 years, every single taxi driver is going to disappear. Potentially, yes. There's something to think about. So, and if it's, and the big question is, should we allow it? Well, if I'm going to save lives, for example, because machine driving is typically better than human driving in statistics. Or still, I might have problems, but statistically, we have less accidents. So, should we allow them to take this and let all the taxi drivers off? Lay off them? That's a good question. Should we allow machines take the job of the doctors and improve the health of the people? Should we protect the doctors against it? That kind of questions. That's more moral. That I was talking about at the beginning of my conference, but I think it's a good point. I think somehow you remember the dinosaurs stuff. I think technology is gonna progress. The sentence of life is gonna progress. I think technology is gonna progress at the end. Let's try to use it in a smart way. So thanks a lot to everyone. So thanks for inviting me here, and thanks for binlogic as well. So that's it. Thank you.